Good morning, is Shabbat Becky Michael, and it's the Success Enlightenment. We continue with our calculus, differential calculus, with application of differential calculus to economic analysis. Now, the question before us today, we're looking at a typical decision making of a firm. Now, as we all know, the firm is trying to maximize their profit. So here we are attempting to maximize the profit given the demand. The firm is faced by cost, and they want to maximize its profit. That is, you want to maximize its total revenue. Revenue means the total income that comes in from the sales of these products. And definitely, the producer produce with the intention that there be demand for the output that they are producing. Now let's look at the question. I believe everyone out there have the basic understanding of the theory. So let's look at the question. We did the mathematical aspect. So the demand for a product fluctuates with price change. This is just quoting the words, the theory of demand. Demand is a function of price. That is, as the price increases, the quantity demanded decreases, and as the price decreases, the quantity demanded increases. That's what that first sentence is talking about. And the demand function is giving those. So they give us the demand function. Now, when we look at this demand function, they give us the quantity demanded is a function of price in such a way that the quantity demanded is equal to 650,000 minus 500p. That is, the higher the price, definitely, the lower will be the quantity demanded. So since it is negatively sloped, this is a demand function. And also, they give us the total cost of producing Q units of the production is estimated as that. This is the general total cost word function. Q stands for unit. If it's producing 1 unit of commodity, the total cost of producing will be what? This Q here will be 1, this Q will be 1, so it will be 500,000 plus 600 plus 0.0015. That will be the total cost of producing it. So now we have our quantity demanded function and we have our what? Cost function. Now, why am I taking time to actually explain the question is because this is just a word problem word question. So you have to understand what you are up against before you can actually take your pen and start calculating it. Alright? So now the task we are asked to use marginal approach to determine the profit maximizing level of output. And we are asked what should be the price charge and what is the maximum profit. In our basic theory, in our understanding, we know we can actually use two approaches. As far as this question is concerned, we have the marginal approach and we have total cost, total revenue approach. And when you use it, you have the same answer. Now, I believe we have some basic knowledge of what this is talking about. Now, we go forward now and we are going to solve this question. We are going to go into the calculations of this question. Now, we are solving the question. Now, what we are given the demand function. We name this as equation 1. How we are given the cost function, which we have successfully named it as what? Equation 2. Now, recall, what we are trying to do is we are trying to find the profit maximization units of the firm. That's the first question. You have to find the profit maximization unit of the firm. That is the profit maximization output. Now, there are two conditions we are given for that. Now, profit maximization condition using the marginal approach. The first condition, which is what the necessary conditions. The necessary condition for it is that your marginal revenue must equal to what? Marginal cost. Which is the same thing as derivative of what? Revenue with respect to Q must be equal to what? Derivative of cost with respect to Q. Which is also the same thing as revenue first the partial derivative rate. Same thing as cost first partial derivative. Now we are all saying the same thing here. We are all saying the same thing. This is the first condition. I call it what? We call it the necessary condition. Now the sufficient condition for this is that what? The sufficient condition for this is what? Is our marginal revenue, derivative of our marginal revenue with respect to Q must be what? Must be less than derivative of our marginal cost with respect to Q. This equals to same thing as what? R11 must be less than what? C11. This is the necessary condition, and this is what? The sufficient condition. Now, before I get into the proper solvings, I'm explaining this. If I'm explaining this, I expect you to just get it now. It's not sufficient to just cram all this. It's not sufficient to just cram all this. Now, marginal revenue equals to marginal cost. What are we talking about there is that the firm want to keep producing. Especially when you start producing, your marginal revenue will definitely be higher than your what? Your marginal cost. Law of variable proportion. The law of variable proportion says that given one variable factor of production with the rest of the factor of production what being constant. Now, the more you are increasing the variable factor of production, at first you will have a what? Increasing return. That is, the marginal products will be increasing. And once the marginal product is increasing, definitely you expect your marginal revenue to be increasing. So, if you get to a point, an additional factors of production, which is the variable you added, will result into what? Into a constant return to scale. That is, it will not increase. It will not increase. At that point, your marginal revenue will be what? Or marginal product will be what? Will be zero. Now, furthermore, a further addition to that production will result into what? Into marginal product what? Being what? Reducing, being negative, decline. This is the necessary condition. Now, you can have this necessary condition, and yet, in that point you have here, you still not be profit maximization quantity of the firm. If this sufficient condition is not what? Is not observed. If this sufficient condition is not observed, so for you to have profit maximization output price, the what? The sufficient and necessary and sufficient condition must be what? Must be observed. So once you stated this, the next thing is this what? You find the what? You check for the necessary conditions, and you check for the what? Sufficient condition. And how do you do that? It means now here you have to find your marginal revenue, and you have to find your what? Marginal cost. Now we already have our cost function here. And from here we already see that what? The derivative of the cost function gives the marginal cost. When you find the derivative of your cost function with respect to Q, give us the marginal cost. But here we don't have what? Revenue. They are not giving revenue, so we have to find out what? Our revenue function. Recall, revenue is equals to what? Price times what? Quantity. Revenue is equals to what? Price times quantity. That's what revenue is. Price of individual sale times the total number of sale. That's the total revenue that comes in. Revenue is different from what? Profit. When we talk about revenue, we're talking of total income that the firm, all the sellers earn from all the goods is sold. Now we're talking about the profit. We are removing the cost from the what? From the revenue. What is left is the what? Is the profit. So revenue is simply price times quantity. Now look at it. One popular mistakes many students make when solving this question is that what? Since they already have their quantity here, what we just do is what? They multiply this by P. So they will now get something like 650,000 P minus 500 P square. And that will be their what? Revenue. Quite alright. That is still their revenue. They are right. But what you have to check in this function here is that what? Now when you look at this, you see Q is expressed in terms of P and C is expressed in terms of Q. Now you want to find the derivative, marginal revenue. You want to find the derivative in terms of Q, which means your revenue function should be expressed in terms of Q, not in terms of P. What am I saying? Now, if you take everything here and you multiply it by P, I said you are going to find your revenue will be equals to what? 650,000 minus 500 P. This is Q times P, which should now give us what? 650,000 P minus 500 P squared. Now, when you find the derivative of this with respect to Q, everything will be equals to what? 0. Because definitely there is no Q in this function. this is still our revenue. Suppose our cost is expected in terms of P. You get the corner. But since we are looking at our marginal revenue, if we are the derivative of revenue in terms of Q, so we cannot just use this function to find our revenue. We cannot take this function here and just multiply it by P. So in that case, the first thing we are going to do with this equation 1 is that we are going to what? We are going to solve for P here. We are going to solve for P in this equation 1. That is, we have to make P subject of the formula so that the function can be expressed in terms of Q. And this is what I'm saying. This is what I'm saying. This is what I'm saying. From equation 1, solve for P. Okay? When you solve for P from equation 1 is what? 650,000 minus 500 P. This equation 1. Q equals to this equation 1. So from here, you make P solid formula. If you make P solid formula, you take P to this side, where you take Q to this side. So when P is coming here, the minus sign change to plus, and when Q is coming here, the plus sign change to minus. So this will now be what? 500 P equals to 650,000 minus Q. So divide both sides will be what? P equals to is 500 P divided by 500 equals to 650,000 divided by 500 minus what? Q divided by what? 500. Now this will give us P equals to, now what is 650,000 divided by 500? This will be 1,300 minus 0.002 Q. Now by this, we've already find our what? Our price. This is our price function. Now we take this word to be what? Equation 3. Okay? This is our price, which is what? Equation 3. Now, from equation 3, now we can now find our revenue. As our revenue is what? It is price times quantity. It is price times quantity. Imagine, price times the number of quantity you sold. That's what we are talking about there. So simply, our revenue here, revenue equals to PQ. So revenue equals to what? 1,300 minus 0.002 Q all into Q. All into Q. So our revenue now equals to 1,300 Q minus 0.002 Q squared. Now with this, we've already find our what? Revenue function. Let me to equation 4. Okay? Find our revenue function in equation 4. I'm already given our cost function in what? In equation 2. So what we are going to do here is now find our what? Marginal revenue and what? Marginal cost. And see if the marginal revenue is actually equals to the what? To the marginal cost. That is, we check our necessary condition. Okay? I believe we are getting it step by step. The first thing I do here is what? Is I establish the two conditions. The necessary condition for profit maximization of the firm and the sufficient condition for profit maximization of the firm. Then I'm now attempting to test or check for this condition if it is what? Fulfilled in the parameters of the questions given to us. Now, I find my revenues because I don't have my revenue. I was only giving cost. I use the demand function to find the revenue. But I cannot use this function directly because it is expressed in terms of P. And I want to find the marginal revenue as derivative of revenue with respect to Q. So which means I have to solve for P, then multiply it by Q. In such way, I will have my revenue expressed in terms of Q. Do you get the gist? I believe you do. So now going further here, what we do here is find what? Marginal revenue and marginal cost. So what we do here is what? Derivative of R with respect to what? Q equals to what? Derivative of C with respect to Q. necessary condition. Are we together? So this is our R. What's the derivative of this with respect to Q? This will give us what? 1300 minus 0.004 Q. This. If I use the sum and power function rule of differentiation, this is what you get. Now, this is our cost function. Now, what's the derivative of this with respect to Q? This will give us what? 600 minus this 15 minus 0.003 Q. Are we together? No, sorry, this is plus. We have plus here. Yes, 600 plus 0.003 Q. That's what we get when we find the derivative. Now, from here now, what we do is what? We take Q subject of the formula here. So we collect the lifetimes and we take Q subject of the formula. So what am I saying in essence? Take Q to one side and take the figures to the other side. So by so doing, we have what? We have 0.003 Q plus 0.004 Q. That's if this goes to and meet this, okay, equals to 1300 minus 600. Are we together there? Yes, we are. So from here, this is what? 0.007 Q equals to 900. See 900? This 300 minus this equals to 700. So Q here will now equals to 700 divided by 0.007. So divide all through by 0.07. So 700 divided by 0.007, what do we have? 400,000. That's our Q is 100,000. Now, let me give you something important here. Now, we've gotten our Q to be 100,000. You see, there's only simple, like little difference exists between students that have A and students that have B in the course. It's just a concept of what? Understanding. Students that have B or C, they might not understand, but they might get the same answer. But it's just that the marker was able to decipher, was able to see that one understands it, the other doesn't understand it. Should in case you find this to be in decimal, so because the answer you get is something like 100,000.56. Now, since it is quantity, the quantity cannot be in decimal. It cannot be in half. It cannot be in half. We are dealing with every unit. So what you are going to do is you cannot leave the answer like this. You have to round it up. You have to round it up to what? To the nearest whole number, because we are dealing with what? Quantity. So in case you solve that and you leave it like this, definitely the marker will have to what? Deduct a mark from your what? From your solution. And before you know it, you're already losing marks. So quantity has to be in whole number when you are solving. When you are solving both in management science and social sciences, quantity has to be in what? In whole number. So we already find our quantity now, dealing with what? Necessary condition. Now we now have to test from this necessary condition that is this sufficient condition, is it guaranteed? We want to check for the sufficient condition. If after checking for the sufficient condition, that is when we can now decide if this is the quantity, if it is the profit maximizing quantity after checking for the sufficient condition. But if you've not checked for the sufficient condition, you cannot conclude if this is a profit maximizing quantity or not. So let's check for the sufficient condition. Now we want to check for our sufficient condition. Now the sufficient conditions is talking about to take the second order derivative of our what? Of our total cost and total revenue function. So since we already have the first order derivative as our marginal revenue, which is this and this, so all we simply do is what? We take the second order derivative, that is we find the what? The derivative of what? 1300 minus 0.004q with respect to q less than derivative of our costs, marginal cost, which is what? 600 plus 0.003q with respect to q. Okay, this is what we are dealing with. So now derivative of this respect to q, this will be what? Minus 0.004 less than derivative of this will be what? 0.003. Now when you look at what you have here, this satisfies the sufficient condition. That is, the second order derivative of our revenue is less than the second order derivative of cost. Okay, the second order derivative of revenue is minus 0.04, which is less than 0.003, which is our second order derivative of our cost. Therefore, we can conclude that the profit maximizing quantity is equals to what? 100,000 units. So this ends the first task we are asked to find. Don't forget, see the way I write my own. After we have concluded this, therefore, the profit maximizing quantity is 100,000 units. It's as simple as that. It's as simple as that. Don't forget the procedures. It's very, very simple. It's very, very simple. Don't forget the procedure. The simple procedure is first, you check for your necessary condition. But after, when you check for your necessary condition, you will find the what? Your quantity. But you cannot conclude that that quantity is the profit maximizing quantity until you check for the sufficient condition. If this sufficient condition turns out that this is not less than this, for instance, if this is minus 0.004 and this is also minus 0.004, in this situation, this will not be the profit maximizing quantity. Okay, until this proves right. Once this proves right, then you can now say that this is the profit maximizing quantity. So from here now, we can go to our second task. Now we've already known our profit maximizing quantity. And we are asked now, what is the price charge for the what? For the commodity. That's what we are asked for. What's the price charge for the what? Commodity. Now recall when we are solving for this, here I say we have to what? Solve for P. So which means we already have our what? Our price function in what? In equation 3. So all you have to do to know what the price charge is what? Is from equation 3, substitute 100,000 for Q. That is what's the price charge when our what? Our quantity is what? Is maximized. That's what we are asked for. So the price charge will now be P equals to what? 1,300 from equation 3, don't forget, minus 0.002 into what? Into 100,000. Okay? So your P will be what? 1,300 minus this times 2. 0.002 times 100,000 minus 200. Okay? So your P now will be equals to what? 1,100. Now, if you are dealing in naira, dollar, whatever the currency you are dealing with, you put it there. So your price charge will now be what? 1,100. This is a price charge. Okay? It's as simple as that. The next question is as simple as that. Which is our second task. The price charge is 1,100. All you have to do is what? Is to find the function of your price and substitute the what? Your maximizing quantity for Q in that function. Then you find the price charge. So the last task we have to do is to push what? What's the profit maximization? Now what's total profit the firm actually make? So what's the profit? So now what we're doing there is what? Profit in economics is usually represented as what? As pi. As pi. So not P, but as pi. Equals to what? Revenue minus cost. Okay. Now you have already your what? Your revenue function to be this, and you have your cost function to be this. So profit is what? Is 1,300 Q minus 0.002 q square minus what's your cost? That's 500,000 plus 600q plus 0.0015 q square equals to profit. This is what profit is equals to. So all you simply do here is what? You substitute 100,000 for q in this expression. So here what we have is what? Is 1,300 into 100,000 minus 0.002 into 100,000 square, 200,000 square, everything here in bracket, minus 500,000 plus 600 into 100,000 plus 0.0015 into what? 100,000 square. Okay, 200,000 square. So from here, what you do is what? You work with your calculator. So 1,300 times 200,000, what does that give you? 1,300 times 100,000. So that gives us, okay, sorry. This will be 1,300,000,000. This 130 million. 130 million minus 100,000 raised power 2. 100,000 raised power 2 times 0.002. What does that give us? That gives us 20 million. That gives us 20 million. That gives us 20 million. Now minus 500,000 plus what? 600 times 100,000. That will be what? 600,000,000. That's 60 million plus, because everything here is in what? Is in minus. Don't forget. Everything here is in minus. Don't ever forget this bracket. Don't forget there's a bracket here. Don't forget there's a bracket here. So 0.0015 times 100,000 square. So 100,000 square. 100,000 square times 0.0015. That gives us 150,000. That gives us 15 million. That gives us 15 million. So what we have to do is what? We add everything here, we add everything there. What do we get? This will give us 20 million minus 130 million. This will give us 110 million. Now, this is 60 million. This is 15 million. This is 500,000. What does the addition give us? This addition gives us this gives us 7,550,000. This is 75,500,000. So what our profit is what? This 75,500,000 minus 110,000,000. our profit will be 345,000,000. So therefore, the profit of the firm is, you put the naira sign there, 34,500,000. So it's 34,500,000. This is the profit. This is the profit maximization of the firm. It is, the third task is as simple as this. Because when I was solving for the quantity maximization, I said you are going to what? Round it up to what? Whole number. But we are talking about price. Price can be in decimal. You can get 1100.45, 1.00.67. You leave it like that. It is price. You leave it in decimal. Okay? You don't have to round it up. Leave it in decimal. Now, the same thing with profit. You can have 334,500,000.7.2.6. You leave it in decimal. Those ones can be in decimal. But quantity has to be what? Round up to whole number. And this is total solution for this word question. So in summary, you just put it. Quantity maximization is what? 100,000 units. The price charge is what? Is 1,100. And what? The profit of the firm is what? Is 334,500,000. So that's how you solve this question. I believe this is well understood. If you see after me going through it with you and you still don't get it well, you can directly message me, WhatsApp me directly. I would love to read. I would love to explain this again. And if you are facing any similar question like this and you try to solve it this way and you didn't get it, feel free to share the question to me. I'll be more than happy to solve it once again and share it to the world. Don't just watch, like, subscribe, and comment. I remain yours, Success Ishola Michael, and this is Success Enlightenment. Thank you.